Hello everyone, my name is Yizhou Shan. Today I'm presenting our work on disaggregated persistent memory. This is a joint work with Xinye Cai and Yin Zhang from Purdue and UC San Diego. A recent trend called resource disaggregation breaks monolithic servers into network-attached resource pools. It offers many benefits and therefore has attracted quite a lot of attention and adoption in academic and industry. Notably, disaggregated storage and disaggregated memory, which separate storage or memory from compute, have seen increasing amounts of adoption in data centers and clouds. Both disaggregated storage and memory offer flexible management and independent scaling of data center resources, which in turn enable more types of applications. So how about persistent memory, or PM? If we can disaggregate the PM, we can enjoy many benefits of disaggregation. It will also be an easy way to integrate PM into current data centers. Can we use existing disaggregated system for disaggregated PM or DPM? The answer is no, because current disaggregated storage systems are designed for SSDs and hard disks. Their software system will be too slow for PM. On the other hand, disaggregated memory systems do not provide durability or reliability and cannot be used to build reliable data stores. So how shall we build DPM? To answer this question, let's first review the spectrum of today's PM deployment models. On the far left side is a non-disaggregation mode, or a traditional distributed PM mode. Regular servers are connected by the data center network. Each server runs application computation and hosts some PM. Some of the PM is used locally, some is used by remote servers. In addition, each server runs a PM management layer. At the center is what we call the active disaggregation mode. Regular servers on the left side run application computation. PM nodes on the right side host PM and run the management layer of this PM. Both non-disaggregation and active disaggregation have been extensively studied and adopted in the real world. However, there's a completely unexplored area, an area we call passive disaggregation. Like active disaggregation, regular servers run applications and PM hosts PM. But instead of running the management layer within the PM nodes, passive disaggregation runs it at the computer servers. This work, for the first time, does a thorough study of passive disaggregation model. With our PDPM model, PM devices only need to have NIC and PM, and they're accessible only via the network. In addition to its disaggregation benefits, PDPM has low capex and OPEX, and avoids any scalability bottlenecks at the PM nodes. Moreover, PDPM is an unexplored research area. Studying it would answer many questions and serve as a guide for future PM research. PDPM is possible now thanks to today's fast data center network and technologies like RDMA that can bypass CPU. With this new model, the natural and the most important question is, without the processing power at the PM, where and how shall we process and manage data? A most straightforward way is to run everything, including data access and PM management at the computer nodes, or CN. This architecture essentially distributes data and control planes to all CNs. A different way is to centralize data and control planes, for example, by adding a centralized coordinator between CNs and DNs. The coordinator could perform all metadata operations and coordinate data access from CNs. A third way is a hybrid model that combines distributed and centralized approaches. For example, the data plane can be performed at the CNs in a distributed way, and the control plane could be carried out at a centralized server. Based on these three architectures, we designed and implemented three KVS: PDPM Direct for the first model, PDPM Central for the second model, and Clover for the hybrid model. All these systems guarantee that reads only see committed data, and the writes are always atomic and are able to recover from power failures. Our results show that Clover, the hybrid model, achieves the best performance among three PDPM systems. The key enabling factor is the clean separation of data and the metadata planes. We also discovered that PDPM offers deployment, cost, and scalability benefits over active DPM models. However, we find that PDPM performs worse under high write contention or with complex operations. We believe future systems could benefit from a hybrid disaggregation model that's in between active and passive, for example, by using programmable hardware at the PM nodes for complex operations. All of our systems are open source. If you have any questions, please reach out to us. Thank you for listening.